Alright, so let's go ahead and see what the graphs of these look like. For example 2, we are going to draw a graph and state the domain and range for each function here. So our first function is going to be f of x equals x cubed. So let's go ahead and grab our calculators here and plug that in to see if we can get ourselves a table of values. So y equals, and then we're going to say f of x, well that is y equals, and then x cubed, so x to the third power here. So let's take a look at the picture. We should see, yep, exactly what we expected, our s curve, excuse me, our cubic function here. So let's go ahead to our table of values and see if we can pull some values off of here. Now, if you notice, our graph is going to be centered around 0, 0, so that's one of the points we should see here. And then we have 1, 1, which will totally fit on our graph. But then our next point, 2, 8, if you count 1, 2, and then 1, 2, 3, 4, 5, 6, 7, 8, that's not even going to fit on our graph. So, our values here, we're really only going to go from -1 to 1 here, because this next one is -2, -8, which we know is not going to fit in that direction either. So what we need to do here is we need to make sure that we keep these on our graph. So the only points we're going to be able to plot here are -1, -1, 0, 0, and 1, 1, which, if you know me, that is not going to be good enough to draw ourselves a little picture here. So let's zoom in, quote unquote, on our table here and see if we can get some better points. So you're going to go into your table setting. And in your table setting, right now we're starting at -2. Let's just go back to 0 because we know that's where our graph is going to start around. And then this little triangle symbol right here is your Greek symbol for delta, which just means your change. So your change in your table right now is set up to change as 1. Now we can change this to be whatever we want it to be. You're going to see here why I've picked 0.2. After you do a bunch of these, you're just going to know what's going to be good to go on your graph here. It's going to be around 0.1, 0.2, 0.3, just depending on your situation. So we're going to use 0.2, and then we're going to go back to our table. So we go second table, and now if you notice, we go 0, and then our next one's 0.2, just like we asked, and then 0.4, 0.6, so it's counting by 0.2s here. So let's go ahead and start plotting points on our graph here. So we're going to get our pen. I'm going to get a color you can see easily on our graph. Let's go with red. So 0, 0, that's easy enough to find. That's going to be right here. And then, well, now we're scaling by 0.2s here. I forgot to scale my graph. Let's go back and do that. So I'm not going to mark every one, but I'm going to mark where 1's going to be at. So here's 0.2, 0.4, 0.6, 0.8, and then this will make that 1 right here. So that'll be 1. And then 0.2, 0.4, 0.6, 0.8, and then 1. Just that way we can get an idea of where our graph's going to be at. 0.2, 0.4, 0.6, 0.8, and 1, but remember this is going to be -1. So -1 here. And then 0.2, 0.4, 0.6, 0.8, and -1's right here. Alright, so now we're ready to actually graph. So let's go ahead and get the red back. Alright, and turn our calculators back on because it might have turned off. There we go. So 0, 0 is already there. The next point we need is going to be 0.2, 0.008. So 0.2, 0.008 is going to be just barely above the 0, 0 line. So right there. Then we have 0.4, so we know the next value is 0.4, and then 0.064 is going to be a little bit higher, not too much though. It's still 0.064. And then 0.6, 0.216, so 0.6 is right here. 0.2, remember these are also scaled by 0.2s, so 0.2 and then 1.6 will just be just a tiny bit above that. So there's your next point right there. Oops, excuse that point. 0.8, and then to 0.5, so 0.2, 0.4, 0.5 will be a little bit above that, actually right in between because the next one's 0.6. And then finally our last point here is going to be 1, 1. That's actually going to fit onto our graph. 1, 1. Now if you notice the next point is going to be 1.2, which will fit. But then 1.7, if we're at 1 here, 1.2, 4, 1.7 is not going to fit on there. So that's as far as we can go in that direction. Now we're missing our whole half of our graph. We know it's going to go down this way. So let's go ahead and back to 0. We're already at 0, but let's go into the negatives. Now we know we're going to make it at least to -1 because we know that that fits. So -1, -1, you can go ahead and plot that, but I'm going to start over here next to 0 and go with -0.2, and then -0.008 is about right here. And -0.6, nope, I skipped one. sorry, I'm going backwards. There we go. Negative 0.4, so negative 0.4, negative 0.064 is a little bit higher, but not much. And negative 0.6 and negative 0.216 is about right here. Sorry, these points look truly awful. And then 0.8, so negative 0.8, negative 5, so negative 1, 2, 4, 5 right here. As you can see, we're just doing the opposite of what we did up there. So the negative 1 is going to be our last point on here. Okay, so now we can connect them, and look, you already see the little S curve that we're supposed to have here. And so then I'm going to go ahead and draw my curve in there, draw a little arrow, and draw my curve in here, and draw an arrow this way. Remember, please make sure you have your arrows on there. Now, as you can tell, this graph isn't the prettiest. Hopefully yours looks a little better done with pen and paper. But key elements, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 points. You should have anywhere between 10 to 15 points on these graphs. So don't be shy. I need to see those. Also, I should see arrows on both ends because we know that this is going to keep going forever and ever and ever. So the next thing they would like us to do is they want us to find our domain and our range for this function. So let's go ahead and do that. And remember, we just spent a couple days doing this. So for your domain, and I would like it in interval notation, please. So domain, remember, domain, all we care about for our domain is our x values. So we would imagine this graph being squished up to our x-axis or squished down to our x-axis, depending on when or what area of the graph we're in. So you're going to have everything in the negatives with an arrow, of course. So we're going forever and ever into the negatives. So that would be negative infinity to, well, this would get squished down. We have no gaps here, so it's going to keep going into positive infinity. So positive infinity. So our domain is everything, negative infinity to positive infinity. So now for our range, let's see what that's going to be. So for our range, we just imagine it being squished up to the y-axis. So for this guy, we get squished up that way, and this guy gets squished down this way. This guy is a continuous line all the way into the negatives, so it again starts with negative infinities. Because of that arrow, it keeps going. And then this guy gets squished up, and that goes into positive infinity. So it goes to positive infinity. So our domain and our range are the same in this case. Not always going to happen, but in this case it does.